All right, folks, back again. 5-6 is on the menu today. We are going to be talking about everyone's favorite, the quadratic formula. I say that because kind of tongue in cheek as a joke, because every year as pre-calc teachers, as accelerated algebra 2 teachers, even as algebra 2 and algebra 1 teachers, it seems like everyone wants to do quadratic formula. They see a quadratic, they want to do quadratic formula. All the students want to, because they feel like they know it. And I'll tell you what, you get it wrong a lot. It really is the last resort. You should only use this as the last resort. But I'm going to break it down a little bit different than what you've seen before. So maybe you'll have more success doing it than you have in the past. So pay attention. You may think I already know the quadratic formula, but we're also going to talk about the discriminant and what it tells us about the roots. Remember, when we solve these quadratics set equal to 0, we're solving for roots, where it's crossing the x-axis. So we want to be able to see that a little bit sooner than when we solve it sometimes. Sometimes we want to just be able to take one piece and say, all right, what are the roots like? Are there two real roots? Are there two irrational roots? Are there two rational roots? Are there one root? All those kind of things. We're going to want to be able to know right away. So there are still some things to learn besides just the straight quadratic formula in this one. So let's go to my notebook, as always, and we're going to do the quadratic formula and discriminant. So let's just go right at it. Quadratic formula. Quadratic formula is when we're solving for x again, we're looking for those roots when a quadratic is set equal to 0, and we can find them at negative b plus or minus the square root of b squared minus 4ac all over, oh, that was a horrible line. I got to make it a little prettier than that. All right, all over twice a. Now, this is when we have a standard form equation where you've got a standard form equation that is where we say ax squared plus bx plus c equals 0, right? That's where we got to get to in order to use this. Now, that thing we call the discriminant. All right, we call it discriminant because it helps us decide. It helps us discriminate as to what the, I should have actually just kept my mouth shut there for a second and written it out before I said discriminate, because it made me write that. It's discriminant. And it helps us discriminate as to what our roots are telling us, what a value is telling us about our roots, I should say. All right. So what is the discriminant? Discriminant is the value we get by finding b squared minus 4ac. And I would strongly suggest you find this value before you do anything in solving anyways. And I say that because you notice what this is. This is just what's under the square root up above. In the quadratic formula, b squared minus 4ac is the value that we take the square root of. If you can find this value first, it tells us a lot about what's going on, because if you think of the quadratic formula in another form, another way of writing the quadratic formula is negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. All right. So if we know this value, we can look at what it tells us. If b squared minus 4ac is greater than 0, meaning it's a positive value, and it's a perfect square, all right, it's something I can take the square root of. If it's a perfect square as well, then we know something right away. We know we've got two rational roots. Why do we know we've got two rational roots? Well, think about what's going on here. If I take the a, b, and c and I put them in here, if b squared minus 4ac is greater than 0 and a perfect square, it means this is going to be a nice number, isn't it? It's going to be an integer. And if this is an integer, then 2a is going to be an integer, negative b is an integer, 2a is going to be an integer. All these things lead us to having two rational roots. I shouldn't say integer. This will at least be a rational expression. This will be a rational expression. And together they'll make at least two different rational expressions, because this rational plus this rational, or this rational minus that rational, it gives us two rational roots. All right. Now, what if that value of b squared minus 4ac is greater than 0, but not a perfect square? If it's not a perfect square, it means when we do this part, we're going to come out with a square root of something still in there. So whatever we have is going to have an irrational number in it, right? So we're going to get two irrational roots. And two other situations. We had greater than 0 in both ways, perfect square, not perfect square. Now, what about if b squared minus 4ac is less than 0? That means we're going to have a negative under the square root. When we get a negative under the square root, what did we learn from this section already? It means we're going to have imaginary, this piece right here is going to be imaginary number. And then we're going to have a real number. When we have a real number plus or minus an imaginary number, what do we call that? That's a complex number, right? So we are going to have two complex roots. And when we have, finally, b squared minus 4ac equal to 0, well, what happens there? Let's think about that. If we have b squared minus 4ac equals 0, then what's under the square root is 0. Square root of 0 is 0. So this whole term goes away and we just get negative b over 2a, right? So that means we have one rational root. All right, so how do we deal with this? All right, this is the basic idea of finding the discriminant, finding that b squared minus 4ac value and figuring out the roots from it. I would go one step further. Every time you're asked these questions, all right, they're going to give you questions of this sort. Let's get a new page. All right, they're going to ask you questions that say this. They're going to say, part A, find the value of the discriminant. All right, then they're going to say, describe the number and type of roots. The number and type of roots. And finally, they're going to say, find the exact solutions using the quadratic formula. All right, and they'll give you something like this. If they gave you x squared plus 12x minus, equals -4. All right. First thing we have to do, if we're going to do these things and we're going to solve A, B, and C, the first thing I would do is get this in standard form. Remember, I said everything we do depends on that in the beginning. So I'm going to subtract, or I'm going to add 4 to each side, and I'll get plus 4 equals 0. So now I have this. I've got a standard form quadratic set equal to 0. And I can say that A is equal to 1, B is equal to 12, C is equal to 4. I think this step right here is incredibly important for A, B, and C. All right, if you're going to get this right, I really suggest you do this, guys, because I've found in years past people get this wrong because they don't know these values. They haven't put this into this form. And this is the big key step. This is where you got to start. Step 1, put it in standard form, find what A, B, and C are, and write them down. All right. If you do that, everything else can fall into place. So now part A, find the discriminant, b squared minus 4ac. All right. B squared is 12 squared minus 4 times A times C. And again, I like to write this down so that you can actually see it. Minus, that's 16. So 144 minus 16 is what, 128? All right, that is my discriminant. That's it. That's the answer for A. All right, that's all you got to get. That is the discriminant. Now, what do we do for B? Well, B asks you to look at this and say, is that a perfect square? When I take the square root of this, does it come out to a nice integer? No. Right? Nothing squared equals 128. So this is not a perfect square. And if we know that's not a perfect square, and it is positive, notice, right? I didn't say that. But as soon as we know it's greater than 0, then we have to say, is it a perfect square or not? It's not a perfect square. So what does that tell me? That tells me that I've got two irrational roots. All right, so we've got part B done. Now, this is where no matter what, if you're doing quadratic formula, guys, I would always find this first. All right, I look at 128, and that's going to be what's underneath my radical, right? For part C, it says use the quadratic formula. This is the way I do the quadratic formula. First, I find out what square root of 128 is. Remember we did that at the beginning of the chapter? We said, how do I simplify this? Well, I did 128, and I did 2 times 64, and that was, I can see this is a perfect square right here. So I'm going to say it's 2 times 64, which would mean this is equal to 8 root 2. Yes? All right? So I've simplified this radical. Now I'm going to actually go to my quadratic formula and say x is equal to negative b. Well, again, what was my b value? I wrote it right up here. B is 12. So x equals the opposite of b plus or minus. I don't have to write the square root of b squared minus 4ac anymore. I just write 8 root 2 because I've already figured it out. This one step of figuring this out before you put it in here saves people so many mistakes, because when you try to do it all underneath the radical, you try to write out what you did in part B all underneath here, you mess it up. Do it separate and just plug it in here. Now life looks easier. And then on the bottom is 2a. Well, a was 1, so that's just 2 on the bottom. So now what do? I simplify this. I can take a 2 out of everything, right? 2 divides into negative 2, or negative 12, negative 6 times. Plus or minus 2 divides into this. It makes it 4 root 2. And I have my solution. That is the exact value of the solutions. Those are my 2 irrational roots that we were looking for. All right, I would do this every time I do quadratic formula. All right, if we're doing another one with A, B, and C. Let's do another one. Let's do this one. X squared minus 7x plus 6 equals 0. So part A, what do I need? Well, I need my b squared minus 2ac. This is in standard form, so I can automatically say this is a equal to 1, b equal to negative 7, c equals 6, right? It's already in standard form, so it's good. So I can do my b squared minus 4ac right here. That would equal b squared is negative 7 squared minus 4 times a times c. This is where people mess up a lot. Negative 7 squared is not negative 49. Your calculator will tell you it is, unless you put the parentheses in here. This is positive 49 minus 24, and that gives us 25. Well, there's our discriminant. Part A is done. What does it tell us about the number and type of roots? Well, 25 is a perfect square, and it is greater than 0. So we have 2 rational roots. And now we can go right to solving. What is the square root of 25? Square root of 25 is 5. So now I can do x equals negative b, so that's positive 7, plus or minus. Square root of 25 is 5, all over twice a, which is 2. And what is that? 7 plus 5 is 12 over 2, that's 6. 7 minus 5 is 2 over 2, that's 1. I've got my solutions. All right, again, this makes it a lot easier, guys. One more example. Let's do this one. 4x squared plus 20x plus 29 equals 0. All right, so what do I got here? I've got standard form. I'm good to go. A equals 4, B equals 20, C equals 29. So now I'm going to find my discriminant. I'm going to do b squared, 20 squared minus 4 times a. That's another 4 times c. That's 29. So this is going to be 20 squared is 400 minus 4 times 29. That is 464. Whoa, 464. That looks really ugly. I'm sorry, guys. I got to rewrite that. All right. 464. That equals negative 64. Well, what does that tell us? Negative 64, it's a negative number. So as soon as we know it's a negative number, those are complex roots, right? So B is 2 complex roots because it's going to involve I. Because we need to find out the square root of negative 64. What is the square root of negative 64? I should have said roots here, guys. Sorry. So this was our answer for B, right? Square root of negative 64 is equal to plus or minus 8I, right? So when we go down here and say now for C, X is equal to negative B, so that's negative 20, plus or minus 8I all over twice A. That's over 8. So what can we do here? Well, it looks like I can take a 4 out of everything on top. So if I took a 4 out, I would have negative, what would it be? Negative 5 plus or minus 2I. And on the bottom, I would have 4 times 2, right? So those would cancel, leaving me negative 5 plus or minus 2I all over 2. And those would be my 2 solutions. You could also write this. The book kind of bounces back and forth, so I don't want you to be thrown if you see this as this, and that translates into negative 5 halves plus or minus I. I don't care which of these 3 forms. This is, I think, the easiest way. Just leave it in that form. But it's up to you. I'll accept anything that's equivalent. All right. So this gives you an idea. We have problems that are going to ask you to use quadratic formula. If they ask you to use the quadratic formula and just say solve, find the exact values using quadratic formula, I tend to still go through these 3 steps, guys. You'll get a lot more right. If you try to punch this all in your calculator right off the bat, you're going to get a lot wrong. I guarantee it. I've seen it year after year. Trust me on this. If you start doing this and writing it down, you're going to go faster than you ever have been, and you're going to get more right. So remember, standard form, find what the discriminant is, interpret what that means, plug it in, and simplify. And you're done. All right? So that was it. That's what we're doing in this section. That's 5-6. That's the last section in our workbook from the Algebra 2 text. So this is going to complete it. We're going to have a quiz coming up, so get to work on the homework. We'll go over it tomorrow, and we will be set, guys. All right.